you find the total value of a combination of positive and negative integers? Today we start the book, Accentuate the Negative. It's about positive and negative numbers and how you're going to do the operations, the basic 4 operations with positive and negative numbers, and how in real life those operations are going to be applied. I will tell you we are going to deviate from the book a little. A lot of what the book does as far as your investigations assumes that you know a lot of the integer rules. So we're going to look at Investigation 1, the first part today, and by looking at the kinds of things they're asking you to do right out of the gate, just the first lesson, you're going to see the need to know those rules. So what we're going to do is after the lesson today, we're going to take Tuesday and do addition, Wednesday and do subtraction, and Thursday we will do multiplication and division together because that rule is the same for both. So we usually do those 2 on the same day. And whenever you go home for Christmas break, we've already gone over the rules and why the rules work for all of the operations with positive and negative numbers. You will get your parent letter for the new book tomorrow. Today you do not have a recording sheet. You're actually answering the problem on notebook paper. You're going to start up under your notes. We're going to take a few notes before we begin with answering the problem. We only get to C today, A through C, but still in doing that much of the problem, you should see that there's a definite need for you to go ahead and know what those rules are from the beginning. It's in that top thing. You know where it is. Just grab one. So, how can you find the total value of a combination of positive and negative integers? Your problem starts today on page 7. So make sure you have a book. It is the Accentuate the Negative book. It is not the Comparing and Scaling book. If someone has accidentally given you one of those, make sure you've got the right one. Page 7, and be careful walking over the fence. Extending the number system. After you write the focus question, draw a number line for me. Doesn't have to be a big one, maybe from positive 4 to negative 4. If you'll go behind my desk in that straw thing and get you a pencil and sharpen it, those are the only ones I have left. Quick number line. There's some words that we're going to go over, some concepts that we're going to go over before we begin the lesson. Now remember, you're going to want to make sure that you're taking notes. Even in one instance today, you are going to need to go back and look at your notes just to continue with the problem. But when it gets to the point in this book where you're taking the partner quiz, you want to be able to help. You want to be able to contribute. Not to sit there and let your partner do all of the work because they're going to get all of the credit. So make sure that you're paying attention and that you're taking notes and that you understand what's going on each step of the way. Page 7. One of the most useful representations of numbers is a number line. A number line displays numbers in order so that their relationship to each other is clear. You can determine whether numbers are less than or greater than other numbers by looking at their position on a number line. If you follow a number line from left to right, they go from least to greatest. So any number that's to the left of another number is less than that number. Any number that is to the right of another number is greater than that number. So if it's to the left, it's less. If it's to the right of that number, it's greater. So you should be able to pick out greater than and less than by looking at a number line. A number line also illustrates the relationship between signed numbers. To avoid confusion with operation signs, now remember our operation signs are addition, subtraction, multiplication, and division. And you'll notice the first two signs look like positive numbers and negative numbers, even though they're really adding and subtracting. So that's what it means to keep from getting the signs confused with operation symbols. It says that you can use raised signs to show negative rational numbers, such as negative 150. And if a rational number does not have a sign, you can assume that it is positive. For example, 150 is the same as positive 150. So what they're talking about when you can use raised signs, if I were looking at the number 3 and it was negative, instead of writing negative 3 like that and getting it confused with subtract 3, they call it a raised sign. They want it very far up on that number so that you can really keep it separate from meaning subtraction. So if I were going to go in here and make sure that I had raised signs, that's what they would look like. That means for a while, be very meticulous at how you put that negative number, that negative on the number. A lot of times when I write them, you will see me put the negative number in parentheses. That way, if I have to subtract a negative, then that's what it would look like. Any questions about that and raised signs? What is the difference between a negative 6/10 and a positive 6/10?
Positive 16 higher than the negative 16.
The positive is the high. How many points to the right of 0 does 6/10 go? 6/10. So where is the negative 6/10?
12/10.
Now a half is here, and we know that 0.6 is going to be a little bit to the right of that. So that's positive 6/10. Where's negative 6/10? That's the half. That's going to be the negative 6/10. The difference in them is that they're the same distance from 0. Or, not the difference, but the relationship. It's asking what's the relationship of the two. This is 0.6 in the negative direction. This is 0.6 in the positive direction. They have the same absolute value. You should know absolute value from last year. Absolute value is the distance from 0. The absolute value is usually drawn in these parallel bars, and that just means I want to know the distance that this number is from 0. Absolute value is always positive. If I walk from here to Dunn backwards, I'm not going to tell you that I walked negative 3 miles. Even if I walk backwards, I'm walking 3 miles. No. But because its distance is positive, absolute value is just distance. How many points away from 0 is this number? So even if I had the absolute value of 6/10, it's still positive 6/10. All absolute value is positive. But because they are the same distance in opposite directions, these numbers are referred to as opposites. So if I had a negative 3 and a positive 3, opposite. 3 points on each side of 0, same distance from 0, just in different directions, are opposites. When you add opposites together, they're called a 0 pair. So if I had a positive 1 and I added a negative 1, where does that put me to? To 0. So they cancel each other out. So you're going to refer to those as a zero pair. So again, doing a few notes before we begin the investigation. So far, absolute value, opposites, and zero pair is what you have down. They also want to know which number is greater, negative 2.3 or positive 1.2. Poncho, do you know? Which one's greater, negative 2.3 or 1.2? 1.2. Positives are always greater than negatives because a positive is always going to be to the right of a negative number. And remember, to the right, that's bigger. To the left, that's smaller. The last one is, how can you use a number line to help you list negative 2 and 3/10, negative 3 and 5/10, and 1 and 7/10 in order? How can you use a number line, Jaden? How do you know, though, by using a number line? Actually place them on the number line. So let's do that. Let's put, and even on the number line that you have at your desk, a negative 2.3, if 2.5 is here, then we know that 2.3 is a little bit to the right of it. So that would be about where negative 2.3 would be. Now it says negative 3.5. That's 3.5. That's where it would be. Now they've got a positive 1 and 7/10. 1 and 7/10 is bigger than 1.5. 1.5 is middle. 1.7 is a little bit to the right of middle. So we're going to say that that's about 1.7. So you can use a number line to order these numbers just by placing them on the number line. Then you know as you get to them from left to right, that tells you the order to put them in. The bigger the negative number, the smaller the amount really is. So least to greatest would be negative 3.5 would go first, negative 2.3 would go next, and then positive 1.7 would go last, if we were ordering these from least to greatest. If we were ordering from greatest to least, we would start on this end and list them as we got to them, moving on the number line. Any questions about that one? Yes, Skylar.
I was doing that at school today.
We're doing 1.1 today, yes. And if you choose to use a number line in that way, now these numbers are rather large today. I wouldn't, you could use the number line, but you'd have to be careful how you numbered it, maybe every 50, depending on the size of the numbers you're going to actually get to and use today. As you work on this investigation, use number lines to help you think and reason about mathematical situations. Again, you're going to use numbers like 200, 500, negative 500, 600, negative 600. So you're going to want to number about every 50, every 100 to kind of not waste so much time making tally marks and breaking it into chunks that we really don't need. Jaden.
When you say it's like a number that you did up on the line, what do you do?
Number it different. Like instead of numbering it every 1, I'd number it every 50. Negative 50, negative 100, negative 150, negative 200. I'd make the chunks that I number it in, the intervals, a lot bigger if my numbers are bigger.
Like, say if there's 2 negatives on it and turn out to be a positive.
We're going to talk about that today. That's only if you're multiplying or dividing. We're on page 8 now. Page 8. You've worked with whole numbers, fractions, and decimals in earlier units. In this unit, you will work with integers. If you have your vocabulary chart, here is your definition of an integer. Integers are the set of whole numbers to the right of 0. They're opposite to the left of 0 and 0. Is 0 an integer?
Yes.
Yes, it just told you. It's all the positive whole numbers and their opposites, which make them all the negative whole numbers, and 0. So 0 is an integer. Integers and fractions equivalent decimals are all called rational numbers. Problem 1-1 involves a game with positive and negative scores. As you work through the problem, think about which operations that you use to keep track of the scores. Notice how the score gets higher or lower depending on whether a team answers a question correctly or incorrectly. 1.1, Playing Math Fever using positive and negative numbers. I'm going to show the launch video first, and then we're going to read about Ms. Bernowski's math class after. So turn your attention here to the launch video.